Okay, let's dive into this explainer. Today, we're unpacking something that has literally become a critical business necessity, the business case for network automation. If you've been following the industry's massive shift toward infrastructure as code, you know we're at a real tipping point here. I mean, we just can't keep scaling manually anymore. The business absolutely demands that our network systems match the exact speed and agility of the software they support.
So you really have to ask yourself, why are we still managing 21st century networks with 20th century manual typing? It's a profound irony, right? We've got this incredibly advanced hardware, stuff capable of moving massive amounts of data in the blink of an eye, yet the way we control it hasn't fundamentally changed in decades. We're essentially shackling spaceships to horse-drawn carriages by relying on these outdated manual command line interfaces. We build complex, globally distributed systems and then completely bottleneck their operation by forcing a human to type out configurations line by agonizing line. It just doesn't compute anymore.
Let's start by looking at Section 1, the cost of manual networks, and specifically that growing tension between manual tasks and business needs.
To really grasp the business case here, we kind of have to revisit the dark ages of manual terminal typing. First off, you've got the heavy burden of manual repetition. You know the drill, logging into 50 different devices just to update a simple access control list or tweak a VLAN. It's soul-crushing work. But the real danger, the actual existential threat to the business, is the high risk of human error. Picture this. You've got a tired network engineer, it's 2 a.m. during a weekend maintenance window. They're staring at a blinking cursor, completely exhausted, and they make a simple, tiny typo in a BGP configuration. Just one wrong keystroke in a routing protocol. Boom! In an instant, that single error propagates, takes down a core router, and causes a massive, highly visible, and incredibly costly network outage. The blast radius of a single human mistake on today's networks is just way too large to leave to chance.
And this brilliantly illustrates our core conflict. On the left, we've got the manual pain points, processes that are painfully slow, deeply repetitive, and highly error-prone. Contrast that with the right side, the absolute non-negotiable business demand. Modern businesses, they don't care that command line interfaces are hard to type into, or that updating hundreds of switches takes an entire weekend. They demand faster operations to match agile software cycles and CI/CD pipelines. They require safer changes to prevent that revenue-destroying downtime we just talked about. And they absolutely need auditable processes to track exactly who did what and when for compliance and security. You just can't achieve agile speed when your network changes move at the speed of a human typing.
So, how do we bridge that gap? Let's move to Section 2, Network Automation Fundamentals, where we transition from that manual pain to automated relief.
Here is our working definition. Network automation is the process of replacing manual terminal-based workflows with code-driven systems to manage and configure network infrastructure. Notice those key words, replacing and code-driven. Look, this isn't just about writing a basic Python script to make a human type faster. No, this is foundational, structural relief. You are handing the repetitive, dangerous work over to a system explicitly designed to handle state and configuration flawlessly. By doing this, you're fundamentally changing the engineer's role from a manual typist to a systems architect. They stop pushing the buttons, and they start designing the logic that pushes the buttons.
To really visualize this shift, look at the stark difference in the workflow here. The manual approach relies on this disjointed device-by-device configuration. You log into your first switch, configure it, check it, log into the second switch, repeat. It's an imperative, step-by-step process that is just incredibly slow and isolated. Now look at the automated workflow. This is a code-driven, network-wide deployment. You define exactly what you want the overall network to look like in code, a declarative approach. You declare the end state, and the automation system safely scales that reality across the entire infrastructure, figuring out the specific commands for you. Whether you're pushing to 10 devices in a local data center or 10,000 across a global WAN, the system does the heavy lifting safely.
And keep in mind, automation isn't just blindly pushing configurations either. It happens in 3 distinct intelligent steps. First, configuration management pushes the desired state to the devices systematically. Step 2 is compliance checking. This automatically ensures the network adheres to your exact security and design standards without a human having to eyeball thousands of lines of text in a config file. And Step 3, validation. This one is huge. It completely replaces that sheer heart-pounding anxiety of hitting enter on a core switch and just praying the change worked without breaking routing. Instead, the system automatically and instantly verifies that the network is performing exactly as intended. It confirms operational status before the engineer even has time to sweat.
Now, what's really interesting about this slide is how it introduces Section 3, the automation mindset shift. This is all about changing how we think about infrastructure entirely. See, adopting the right software tools is really only half the battle. The operational mindset absolutely has to evolve. That traditional approach of typing commands in a terminal, it's entirely reactive. It treats network devices like a collection of fragile artisanal pets that need constant delicate handholding and custom configuration. But the new reality is managing infrastructure as code. It's treating your hardware like cattle rather than pets. This means managing your network with the exact same rigor software developers use for their applications. You write your configurations in code, you put that code into version control like Git, you have your peers review it via pull requests, and then you deploy it systematically through a CI/CD pipeline. No more cowboy changes directly on production equipment.
The absolute bedrock of this entire philosophy is the source of truth, or SOT. Think of this central database as the architect's blueprint. It definitively outlines the intended state of the network. If you're going to automate at scale, your system cannot be guessing what the network should look like based on whatever happens to be running in production at that exact second. It needs a single authoritative anchor, like a centralized Git repository or a specialized database application, and that is exactly what the source of truth provides. It's the absolute master record of how everything, from your IP addresses to your VLANs, is supposed to be allocated.
So the crucial point here is that the database defines the intended state, not the network device. Back in the old days, if you wanted to know how a switch was configured, you logged into the switch and checked, right? The device itself was the master record. Well, in the automated era, we completely flip that dynamic. The central database dictates reality. If a device is manually changed in the middle of the night and strays from the database, something we call configuration drift, that device is now considered wrong. It really doesn't matter what's running in production. If it doesn't match the source of truth, the automation system is going to seamlessly and ruthlessly override it to enforce compliance.
Which leaves us with this final, provocative thought to wrap up our explainer. If your network source of truth is a central database, is your code ready to govern reality? Because once you strip away the manual typing, the safety nets of going painstakingly slow, and those old terminal windows, you are handed this incredible, unbridled power to deploy infrastructure changes instantly across the globe. But with that massive power comes the immense responsibility of ensuring your code, your testing pipelines, and your peer reviews are actually ready to take the wheel. It's a fascinating paradigm shift, and one that modern businesses absolutely must make to survive in an agile world. Thanks for joining me on this explainer, and I hope it really helped you visualize the imperative future of networking.